A zero order gaseous reaction A to B with a rate. So this is zero order, does not depend upon the concentration of A or B. This is always constant of 100 mole per liter per minute. So that's a zero order reaction happening within the reactor. It's carried out in a mixed flow reactor, which is this one, whose volume is 1 liter. So the rate of reaction would be equal to, if you just multiply by volume, that would be 100 mole per minute. Pure A is fed to the reactor. Pure A is fed to the reactor at the rate of 1 mole per minute. This is for time t less than 0. So this problem is in two parts. First, time t less than equal to 0. This is what is happening. At second part is at time t greater than equal to 0. At time t greater than 0, the outlet flow is stopped. So what happens? This outlet flow is stopped. There's no outflow coming out, while the inlet flow rate and the reactor temperature remains constant. So this inlet flow rate remains constant, the reactor temperature remains constant, means the value of K also remains constant. It's a zero order reaction. Assume that the reactor was operating under steady state before the flow was stopped. So this is assumed to be at steady state. And this of course should be equal to on steady state. Um, we have to find out the rate of consumption of A, negative of dC over dt, negative of dC over dt at time t is equal to 1 minute. See what happens at time t less than equal, t less than 0. At that time, the rate of reaction is this is a zero order reaction. If you the rate of reaction will be equal to minus of Ra times V, which would be equal to, you multiply this divided by 1 liter, multiplied by 1 liter, so that would be equal to 100 moles per minute of A would be consumed. And you can see that A is entering at the rate of only 1 mole per minute, so the entirely all the A would be consumed, and there will not be no A in the outlet stream, and this is entirely filled with B. Okay. At time t greater than equal to 0, what happens? This outlet flow is stopped. So if we write the uh, unsteady state mass balance equation, which is accumulation is equal to input minus output plus generation minus consumption, and here we writing for A, component A, so we can write V is of course constant, dCA over dt, that is inside the reactor, that will be equal to input, which is equal to of course F as 0, minus there is no output stream, cancelled, and there is no generation of A, so this is 0, and the consumption of A is equal to it's of K into V. So we can say negative of dC over dt would be equal to K minus Fs0 over V, and that would be equal to 100 minus 1 mole per minute divided by V is 1 mole per minute divided by 1 liter. So that would be equal to 99 of mole per liter minute. So this is the correct answer.